Where was I? So, multiplicative inverses, right. So when I take E and I times it by D, and I mod it by the totient of n, which is p minus 1 times q minus 1, it's going to give me 1. Now, how does this knowledge help us at all? Well, since we already broke in and stole my encryption private key, but we don't know the decryption, I have two. Oh, well, if I have n, right, n's public, it doesn't really matter who has n. And if we all have n, and I stole E, then we have, and we could find the factors of n, then we'll actually have two pieces of the puzzle. Right? Two pieces of the puzzle. We'll have E, and we'll have the totient of n. So then, now all we have to do is focus on factoring n. And it's kind of really big. We factor n, and then we get p minus 1 times q minus 1. And then after we get that, then all we really have to do is we have to find what D can multiply with E to equal 1 when modded by the totient of n, which we could use, the same GCD algorithm and then substitution to get the inverse, multiplicative inverse, same thing that we've always kind of been doing. So how do we find n, or the factors of n? A good way to start is, if it's really big, then you square root n, and you get that number, and then we just round it off to 566, and we make that t. Now we do t squared minus n, all under the radical, right? So all that really did is made sure that t squared, well, that, because all that really made sure is that t squared is going to be bigger than the square root of n. So when we square it, it's going to be bigger than n. So t squared minus n, when it's, I have this all written down from this class lecture thing, but when t is 566, then we're actually going to get some kind of decimal, which is 18.2 or something like that. Since as a decimal, it's a no-go, right? And I'll tell you why later. So if it doesn't work with that t, we just add a 1 onto that t, and we just keep working from there, right? And this is all like one of Fermat's laws, the mathematician Fermat, spelled like Fermat. So we just do this again and again. Now t squared is going to be 577 squared minus n. And then I think that's approximately going to equal, remember this whole thing gets square root after. I think it's going to be approximately 38.3, still decimal, whatever. And we just add a 1 to it again. So now t is equal to 568. And then now we do the same thing, 68. 66. Okay, that was supposed to be 67. It's still the same result because I did the calculations before. So now we do it again. 568 squared minus n being this. And then we square root it. And hey, we get 51. So here's the reason why we wanted it to be a whole number, right? So we wanted it to be a whole number because once we have a whole number, we could actually take this little formula, right? T, and the formula is going to be t squared minus n, and then since it was a square root, then we get whatever, let's call this s, right? So s was whatever we got from doing this, but actually if we square everything, it's going to be t squared minus n equals s squared. Now, does this formula kind of look familiar to you? If it doesn't, it's okay. I'll show you why it should. So if we add n to that side, t squared equals s squared plus n, and we subtract s, t squared minus s squared equals n. Then now, do you see anything? This can be factored. So this actually factors into t minus s, t plus s equals n. And then if you work it all out, then the two factors actually end up being 517 and 619.